Today we're going to look at two rules for derivatives, the product rule and the quotient rule. It's how we take derivatives when we're multiplying functions together or just dividing them. And they're very easy to do. The product rule says we have two functions, f times g. The rule says basically what we're going to do is we're going to write out the first function. So we can get f of x times the derivative of the second. Plus we can take the second, g of x, multiply it by the derivative of the first. Like so. This is our product rule. So basically it says take the first, multiply it by the derivative of the second, plus the second, right here, times the derivative of the first. Or as I say, 1d2 plus 2d1. Now the quotient rule is a little harder. For me, this is the hardest one. Very simply stated, we're going to take the bottom, we're going to take g of x times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. Now this one I memorized it by a song, and it goes low-de high minus high-de low all over low-low. Low-de high minus high-de low all over low-low. So I go low-de high minus high-de low all over low-low. That's how I remember it. So let's take a look at some examples. These are very easy to do. You can really enjoy these. So let's take a look at the first one. Y equals 2x times the cosine of x. Now if you notice for this one, we're multiplying two functions together. 2x times cosine of x. So sometimes I can distribute. Like if I have something like 2x times x plus 3, I can distribute and get 2x squared plus 6x. And I can use our power rule for that one. But this one, we can't distribute, so we have to use our product rule. And this is what it says to do. Just write out the first. So when I take the derivative, we'll call it dy dx. I'm going to write out the first, 2x, and then it says to multiply by the derivative of the second. That becomes negative sine of x. Plus, take the second, the cosine of x, times the derivative of the first, which is 2. The first times the derivative of the second, plus the second times the derivative of the first. Very easy. And I could rewrite this if I wanted to. I get negative 2x sine of x plus 2 cosine of x. And there's our derivative. So let's take a look at another one. Let's take a look at just a couple more using the product rule, and then we'll go into the quotient rule. So let's take a look at number 2 here. Alright, number 2. Let's say we have f of x equals to the square root of x times x squared plus 3. There we go. And we want to take this function's derivative. Very simple. The derivative said, but first, oh no, I got the square root of x. I don't like that. I'm going to write that as x to the 1/2 times x squared plus 3. I'm going to rewrite that. So now when I take my derivative, there's my first, there's my second. So the rule says, just copy down the first, multiply that by the derivative of the second, which is just 2x. Plus, we're going to take the second, x squared plus 3, multiply that by the derivative of the first. Now, there's another way we can do this one. We're going to see y equals square root of x all the time. One, I can just remember it's just 1 over 2 root x. Most people don't remember that, and that's okay. This is just our power rule. So we get 1/2 x to the negative 1/2, subtracting 1. We don't like negative exponents. I'm going to clean this up a little bit. That becomes x to the 3/2. You're adding the powers. Plus, this becomes x squared plus 3. Don't distribute. This becomes times 1 over 2 root x, which is what we said over here. You can simplify that more if you so desire. I wouldn't worry about it. Just leave it alone. There's your derivative. Number 3, an easy one, but I wanted to add something here. Let's try this. X squared times sine of x plus, let's do 3x squared. Well, let's make this an x cubed then. Let's make that an x cubed. There we go. So when we take the derivative, now notice we have two terms, but this term is a product rule. This one over here, just the power rule. So when we take the derivative, we're going to do the product rule first. Take the first, x cubed, multiply it by the derivative of the second, which is cosine of x, plus the second, I'm just going to write that as sine of x, times the derivative of the first, 3x squared. Now I've taken care of the product rule, but I still have this power rule. So when I take the derivative here, this is 6x. If you do this right, you will be 6x-ful. Haha, yeah, I'm that funny. And there is your derivative. So for the next few examples, we're going to take a look at some quotient rules. Those are some power rules. So let's take a look at quotient rules. Let's say we have f of x equals sine of x over x cubed. I want to take this derivative. Well, my quotient rule says, remember my quotient rule says remember my quotient rule, let me bring it back up here real quick. My quotient rule says take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Low-de high minus high-de low all over low. So when I take the derivative, it says take the bottom, x cubed, multiply it by the derivative of the top, which is cosine of x, minus the top, sine of x times the derivative of the bottom, 3x squared, all over, be careful, this is x cubed squared. So if I clean this up a little bit, I want to show you something here. X cubed, cosine of x, I'll put the 3x squared out front, sine of x all over x to the 6. And if you notice, I can actually kind of simplify it. Now you can leave your answer like this, that's fine, but I can also divide everything by x squared. So I can get my derivative, if I want to clean it up, x cosine of x minus 3 sine of x over x to the 4th. And there's your derivative. Very easy to do. So let's take a look at another one here. Whoa, let's take a look at another one here. Number 5. Ready? Number 5. Hold on here. Let me see if I can get the refocus again. Technology issues, and come on. There we go. So let's see if we can try number 5 here. Y equals cosine x plus x squared over x minus 1. Okay, so when I'm taking the derivative, it's again quotient rule because I'm dividing. It's a quotient because I'm dividing here. So the rule says take the bottom, x minus 1, times the derivative of the top, sine x, negative sine x plus 2x minus the top, cosine of x plus x squared, and the derivative of the bottom is just 1. All over the bottom squared, x minus 1 squared. We're not asked to do anything with it, so you know what? Don't be a hero, just leave it alone. Certain things in life say don't touch me, and that's definitely one of them. So, number 6. Alright. We're going to take a look here real quickly, then we're going to do a super duper hard one, and we'll take a break. Okay? So, what if I give you this? F of x equals sine x over cosine of x. Well, if we want to take the derivative, again, it's quotient rule. It's the bottom, cosine of x, times the derivative of the top, minus the top times the derivative of the bottom, which is negative sine of x, over, what do I do here? Cosine of x squared. Now, you don't have to know much pre-cal to be really successful here, but you should know this is cosine squared of x plus sine squared of x over cosine squared of x. Now, you can leave that as your answer, but I can clean that up, because what's cosine squared plus sine squared? From pre-cal, you learn that's just 1 over cosine squared of x. And you can even go further, that's just a secant squared of x. So therefore, we just said that the derivative is secant squared of x. Now, you know from pre-cal, that's just sine over cosine. which is tangent. So therefore, we just said that the derivative of the tangent of x is the secant squared of x. And you can use this method to prove all the other ones, cotangent, secant, and cosecant, and all of them, which we'll talk about in another lesson. So if you go to part 2, I'm going to take a look at a super hard problem. You want to take a look at part 2, and we'll take a look at some trig ones, okay? See you then.